Hi everyone, my name is Jackie and I'm a part of the dopamine group, so I will be talking about dopamine as a catecholamine neurotransmitter. So let's talk about dopamine. First is the synthesis of dopamine. It's out as tyrosine and then is synthesized to dopa by tyrosine hydroxylase, and then dopa is then synthesized to dopamine by dopa decarboxylase. There are two dopamine receptors. The first is D1, which includes two subtypes, D1 and D5. And then there's the D2 receptor, which includes four subtypes, D2A, D2B, D3, and D4. More on the dopamine receptors. So first, the D1 receptor is actually metabotropic and excitatory, while the D2 receptor is metabotropic and inhibitory. So let's have a quick quiz for yourself to see where you're at. So first question, what is the synthesis of dopamine? Name the receptors and subtypes for dopamine. Are these receptors metabotropic or ionotropic? Are these receptors excitatory or inhibitory? Great job. Now check your answers in the document titled Dopamine NT in the dopamine folder. Let's continue. So next is the dopamine pathways. So dopamine is one of the neurotransmitters that has more of a complicated set of pathways. The first one is the hypothalamus pathway, which starts in the hypothalamus and goes to the pituitary gland. Next is the mesostriatal pathway, which goes from the substantia nigra to the basal ganglia. Next is the mesolimbocortical pathway, which goes from the VTA to the cortex and the limbic system. So for the functions of each of these dopamine pathways, the hypothalamus pathway works with hormones, while the mesostriatal pathway works with movement regulation, and this is one of the pathways that's affected in Parkinson's disease. And lastly is the mesolimbocortical pathway, also known as the reward pathway or the pleasure center, and this deals with motivated behaviors. And so dopamine has a really large effect on addiction. So actually right here is the VTA, and this is a simplified drawing. So when action potential happens and dopamine is released in the nucleus accumbens, this is what causes a feeling of euphoria. So another quick quiz to have a check-in with yourself. What are the three dopamine pathways? What function does each pathway serve? What does dopamine have to do with addiction? Awesome. Now check your answers in the document titled Dopamine NT in the dopamine folder, and we're going to continue now with a quick video. So here's a video of me drawing the basic neurotransmitter of dopamine within the cell. So I'm going to be reviewing the basics of the cell and how action potential works, just a review for everyone for the final. So at the receiving end of the cell, there are the dendrites, and these dendrites receive either excitatory or inhibitory signals from other cells. And once the threshold is reached, which is negative 50 millivolts, at the axon hillock, sodium is able to come in and potassium comes out, and this causes the cell to become positive and action potential to go down the cell. This action potential then allows for the calcium channels to be opened up and calcium to rush in. Calcium then binds with calmodulin, and this combination allows the vesicles that contain the neurotransmitter of dopamine in this case to move and fuse and to spill in to the synaptic cleft. There's also something called MAO, which is a naturally occurring enzyme that breaks down dopamine. As I mentioned earlier, there are two receptors for dopamine. The first is D1 and the second is D2. Both are metabotropic, so they have a little G protein here. And D1 is actually excitatory, while D2 is inhibitory. So both those receptors change the firing rate of the following cell. Thanks for listening to my quick presentation. If you're interested in seeing how certain drugs interact with dopamine, check some of the following out, categorized by the type of drug they are, and have a good time studying. Thank you.